All right, so part two, we're going to simplify radical expressions by rationalizing the denominator using conjugates. So I suppose the best place to start is to talk about what a conjugate is. Conjugates are things that are related or connected to each other. So when we talk about conjugates, I want you to think about this. Conjugates, for what we're speaking of right now, are the sums and differences of the same two terms. So here we have two different terms, 2x plus 3 and 2x minus 3. They're connected, but they're slightly different in that they have different signs. Now we need to remember that the product of conjugates is a difference of two squares. So if we were to write this out as 2x plus 3 times 2x minus 3, we would get 2x times 2x, which is 4x squared, minus 6x. When we do the outside, the inside gives us positive 6x. And then the last gives us negative 9. These are going to cancel out. It's going to leave us with 4x squared minus 9. The product of conjugates is a difference of two squares. Now, the same thing works when we are using radicals. The square root of 7 plus the square root of 3 and the square root of 7 minus the square root of 3 are conjugates. So the product of conjugates is a difference of two squares. And what we get if we multiply those two together, the square root of 7 times the square root of 7 is just 7. Square root of 7 times square root of negative 3 is the negative square root of 21, plus the square root of 3 times the square root of 7 is positive square root of 21, and then these two leave you with the negative of 3, because the square root of 3 times the square root of 3 is just 3. Again, these cancel out, leaving you with 7 minus 3, or 4, because the product of conjugates is a difference of two squares, and that's what we are going to base everything that we do in this lesson on. In our last lesson that we do not want radicals in the denominator of a fraction. So we've got to find a way to get rid of these. But in this case, we don't just have one, we have two, and they're being subtracted. So what's an easy way to get rid of those? Well, it just so happens that we can use conjugates for that purpose. We can multiply this by, on the bottom, the square root of 7 plus the square root of 2. And then, of course, because we can't just multiply things without consequences, we have to multiply by 1. And to do that, we'll multiply by the square root of 7 plus square root of 2 on the top as well. And it's important to remember you're multiplying by the conjugate, so you've got to change that sign from negative to positive. When we do that, we will remember that on the bottom we're going to get, since it's a difference of two squares, we're going to get 7 minus 2, because square root of 7 times square root of 7 is 7. Square root of 2 times square root of 2 is 2. And on top, we're going to multiply the 10 by both of those, which is going to give us 10 square root 7 plus 10 square root 2. And then we will simplify just a bit further, and we'll get 10 square root of 7 plus 10 square root 2 over 7 minus 2, which is 5. Now, that, of course, is 10 square root 7 over 5 plus 10 square root 2 over 5. And those can be simplified. Right, so that will leave us with 2 square root 7 plus 2 square root 2. And we are finished. And it wouldn't be any fun if we didn't end our lesson with an application problem. This one's particularly interesting in that it uses golden rectangles. And some of you may be familiar with the idea of the golden rectangle. It's that typical kind of rectangular shape that we see. It's kind of, it shows up in nature, it shows up in art a lot because it is just very common. The golden rectangle has a very specific ratio, and it is a ratio of 1 plus the square root of 5 to 2. We're going to use that to solve this problem. Fiddlehead ferns naturally grow in spirals that fit into golden rectangles, you can see there. What is the width W of the fern shown? We've been given a ratio, and we have been given another ratio. So in order to solve this problem, to find out what W would be, going to use a proportion. We'll use a proportion. So we'll write our first ratio, which is length to width, right? So both of these have to be length to width. We'll set up our proportion. Our length to width ratio is 1 plus the square root of 5. So the length is 1 plus the square root of 5, and the width is 2. And in our problem, the length is 4. And the width is W. And at this point, it's a simple little proportional problem. We'll multiply 2 times 4, and that's going to give us 8. And we'll multiply W times 1 plus the square root of 5. And when we get that, we can see very quickly that we can isolate W simply by dividing on this side by 1 plus the square root of 5. 1 plus the square root of 5 there. We'll divide there, and we'll divide on this side by 1 plus the square root of 5. And that's going to give us a fraction there. This will cancel out, and we'll see that w is equal to 8 over 1 plus the square root of 5. And what's wrong with that? Well, we have a radical in the denominator, not acceptable. So what we've got to do is multiply. Let me go ahead and erase that. We'll multiply by the conjugate. We'll multiply by the conjugate. And that will give us 1 minus the square root of 5 on the bottom and 1 minus the square root of 5 on the top. And we'll multiply by those. Well, on the bottom, we know since it's a conjugate, it's going to simply give us 1 squared, which is 1, minus square root of 5 squared, which is 5. And on the top, we're going to have 8 times 1, which is 8, minus 8 times the square root of 5, which is 8 times the square root of 5. And then we'll take that over, because we know that 1 minus 5 is really negative 4. And 8 minus 8 times the square root of 5. And as we said before, that's actually 8 over negative square root of 4, negative 4. And this portion will be, we're going to add that to, and this is going to be a positive, right? So, but we'll write that out as negative 8 square root 5 over negative 4. And when we get that done, we'll have 8 divided by negative 4, which is negative 2. And we're going to add that to a positive because we're dividing a negative by a negative. That's going to be 2 square root 5. And our answer will be negative 2 plus 2 square root 5. So, fairly simple application of using the conjugate to simplify a radical expression. You should be good to go.